Thank you, HEXACON. I'm really thrilled to be on stage today. So I'm Nicolas Joly. I work for Microsoft. I'm at the MSRC in the VNM team. And yes, I'm going to talk about SSRFs affecting cloud services today. So why that talk, and why am I not talking about memory corruptions today? Well, that's a good question. So my background is indeed memory corruptions and exploit writing, and I've been doing that since forever. And at VMSRG, no, we've got pretty much a unique visibility of memory safety issues. We see a lot of them. We see finders investing time trying to find some and sending out proof of concept. But when it comes to creating a working exploit, then that's a totally different story. So the reason why? Well, there are many, because it takes time, hundreds of hours easily, because it takes skills, it takes experience, and well, you pretty much need to be very smart to do this kind of thing. And one point given, they do make a really good talk. At the MSRC, I lead the purple team, and very often we get to target cloud services that are just not prone to memory safety issues. Why? Because they are written in .NET, in Golang, in Rust, so we can just not use memory corruption issues for the services. We need to be creative. We need to go after something else. And by something else, I mean, for example, SSRFs. So these kind of issues are absolutely terrible and terrifying. Think about, for example, the latest attacks on Exchange. The amount of damage that you can do with something like that is absolutely tremendous. Those attacks are literally devastating. And the reason is that they are simple to make, you don't need much skills to find them, and you don't need much skills to exploit them. So in this talk, I'm really going to give some examples based on my research, especially on AKS, Azure Kubernetes Services. So most of the SSRFs are quite easy to find, obvious to find. Some of them are slightly maybe harder to find. So I'm going here to give just some quick examples on where, basically where and how to find them. And in the end, I just give another example on something that affects Office Online. All right, sounds good? So no way for me to start this presentation without giving you a brief introduction to AKS. Quickly see how it works. So I'm assuming that you have already an idea of what Kubernetes is. Basically a solution to run containers. So when it comes to AKS, really you've got two different parts. You've got one part that is hosted on Azure, so basically the CCP, the control plane. So in this part, you have highly privileged pods, things like the API server, for example, etcd, stuff like that. And there's pods where the customers literally don't have access to them. They can send HTTPS requests to the API server, but they can't RDP or SSH to those pods. It's not possible. And on the other side, you've got all the customer nodes. So this is where the kublets are running. So where you get to run your tasks. And here, basically anything is permitted. So when it comes to the security model, basically whatever happens on the customer nodes, that's fine, because those VMs are isolated. Customer can decide to run whatever. Hopefully that should be fine. But if something happens on the Azure infra, then that's a totally different story. And this was the scope of our review when we decided to take on that. So no way again, I can start this talk without giving some example of past research. So there was one exploit that was sent to us about 3 years ago from two French guys, Christophe Auquier and Brice Augras. This is really one of my favorite exploit chains that I've seen. Even the title is fantastic, half-blind SSRF, but what is it? So these guys, they decided to target the control manager, which is on the control plane, on the CCP. And they realized that they could load some storage volumes in there and set some settings that would allow them to make HTTP requests directly from the CCP. So a typical SSRF issue. But they didn't stop there. And this is where things get really funny. So they realized that they could target a specific version of Golang which had an issue in the way host names were treated. So basically, they found a way to insert some new lines character into a URL, and when Golang was supposed to fetch that URL, it would just basically send all the packets at once, and that would lead the attacker to send many HTTP requests at the same time. So obviously, in the context of a control manager, that was literally a disaster, because suddenly you were getting all sorts of desynchronization issues. And then what we figure out is that they could read all those unexpected HTTP requests and response in the logs because of extra verbosity. This was absolutely terrifying. So if you're not familiar with that, have a look at the blog post. It's well explained. There's just one thing that is slightly blurry to me is how much time it took them to find out this attack. So I say a couple of pizzas and a few pints. Really, guys, seriously, if you have things like that, just send them to me, and I'll be happy to pay you the bit for that. Right, this was really amazing research. So 3 years after, where are we? How do we find stuff like that? I need to say that my background is Windows. When it comes to Golang, Kubernetes, Linux, I'm not the guy. I have literally no skills at that. So how do I find this kind of thing? Am I going to look at the common deployments on AKS? Am I going to look at the pods that are there? You've got like stuff like Cup Proxy. You've got other stuff that deals with Azure storage. Yeah, maybe. So I think that the most common target would probably be the API server, but then you need to think a bit about that, because if you target indeed the API server, then you are actually targeting Kubernetes. And Kubernetes, this wasn't created like last week. This has been audited by many people before and skilled people. So what are the odds that me, Nicolas Joly, who's a noob at that, is going to find some bugs in there? Well, probably very small. Let's think also about log ingestion. As I said, Kubernetes is creating tons of logs, so maybe we could try to hack that. But well, if you think a bit about that, then you're probably going to attack directly the service that is managing the logs. So that's slightly out of scope in here. Like you could think about an attack on Custo, well, Azure Data Explorer, for example. So, well, I didn't really know where to start, but what I wanted to get my feet on was definitely a customer VM. Well, a VM where I could see the kubelet and what was going on in there. So there are some documentation on the Microsoft website where you can just see the steps needed just to RDP on those VMs. So here, I'm just showing an example running on Windows because once again, I like Windows. If you prefer Linux, yeah, that's fine. You can SSH as well. So what did I do? I just installed common tools like Procmon, Process Explorer, etc. Even WinDebug. And then I also set up burp. So it took me just a bit of time to really get it to work and manage to see all the requests sent to the API server. If some of you are trying that and having issues, just ping me and I just tell you how I did. You can see on this capture that the traffic generated by those nodes is phenomenal. Like here, 13,000 requests. So that's a lot. So what did I do? I looked at some of them. I tried to play with those requests, trying to replay them, change settings, trying to try some request smuggling stuff. I played with HTTP streamlining, played with HTTP1, HTTP2, stuff like that. How much do you think I found in the end? Yeah, I found 0. Yeah, yeah. Well, what were the odds, really? It was expected, actually. It would be very surprising to find such low-hanging fruits within a couple of weeks with basically no experience on that. But you know what? I'm convinced that there is always a way. And if you haven't found something, then that just means that you just haven't dug enough. So in my case, I just kept digging, and the light came at some point when I was looking at the logs and I was realizing that there were plenty of requests that actually I couldn't see in burp. So why is that? I'm talking about requests like readies or basically the readiness probes, the liveness probes, the metrics probes, etc. So why is that? Why was I not seeing those requests? So let's come back a bit to the architecture of Kubernetes. So communications really are two-sided. So what I was seeing with burps was basically that orange arrow here. So anything that was coming from the kubelet and sent to the server, that I could intercept that because of the HTTP proxy environment variable. Yes, but there are also scenarios where the API server needs to talk to the kubelet. And here, you cannot just rely on the kubelet to come to you. You need to be able to send messages directly to the kubelet. Kubelet is actually acting as a server here. And those messages, they are sent with connectivity. And once I realized that, yeah, that was the reason why there were plenty of requests that I wasn't seeing. I was just not looking at the right at the right spot. So here is why WinDebug was my friend. So I attached WinDebug to kubelet.exe, and obviously those communications were on HTTPS. So if you put a breakpoint on TCP on socket send and socket receive, then you are not going to see anything. Well, you see stuff, but that would be just encrypted traffic. So I took a trace, and within a couple of minutes, half an hour maybe, I was able to spot at least 2 locations where you could just put breakpoint and then use WinDebug scripts just to dump the memory. And so this is just a short video to show you what happens when you do that. So I'm just attaching, setting on my breakpoint, and then hitting go. And then here you can see tons of requests sent to kubelet. So you can see HTTP1 requests, you can see HTTP2 requests, you can see metrics requests, literally tons of things. And so this video should end with that helps LFC request. So let's just have a look at this helpset request. What is that about already? So look at, for example, this X forwarded for header. So I went quickly at the beginning on the pods and deployments, but maybe some of you have noticed that some of the pods had an IP starting with 10.200, I think. Here, the IP that is given here has nothing to do with that 172 dot something. That's an IP, and that's an IP on the CCP, on the control plane. So these were the requests that I was missing. Helpset request, metrics request, and obviously the other thing that you can see is the response. So here we are basically manning the middling of the traffic coming from the API server. So once you have that, what is your next step? What is the next thing that you are going to do? Well, yeah, obviously you are going to tamper with those requests. And so here, WinDebug is very useful again. You can just quickly write a script that will intercept those requests. So here, the snippet that I'm giving here is basically intercepting all the responses that start with HTTP/1.1. And if it finds one, it's just going to try to redirect it. And guess what happens if you do that? You get some very nice SSRFs from the control plane. So suddenly you are able to basically get more or less the same behavior that my 2 French friends found 3 years ago. And those requests, they come from different pods from on the CCP. So that's pretty good. One question that you may ask is, I use WinDebug here. So I was chatting with Renaud yesterday from Synactive, who said, we want something quick and dirty. We want results. And that's definitely a quick and dirty way to get results. I could have done things probably differently. I could have, I don't know, maybe recompile kubelet.exe. Well, I don't write Golang, but yes, perhaps that should have been possible. Another thing that you could have think of potentially is instead of debugging kubelet.exe, you could have potentially killed the service and instead started your own web server with the right certificate on that. So that could have worked, but the problem here is that the VM is run on Azure Batch, and so there are regular probes sent to kubelet.exe. Well, basically, the service just makes sure that kubelet.exe is still alive. And if you kill it, then well, at some point in a few minutes, then the VM will just restart, and well, you'd have lost everything that you were doing. So this way might work, but once again, it's probably not the best one because well, you might not see the right request at the right time, and well, and once again, the VM might reboot. well, you don't want that. So let's see if we can see the same pattern again elsewhere. Oh, one thing that I forgot to mention, geez, sorry. One thing that I forgot to mention is that those probe requests, I think that when I reported that bug to the team, they fixed them in about 50 different locations. So these issues was really widespread in the code base. So moving on, where else could we see these kind of things? It was something just to try directly with kubectl to try to fetch some logs from a pod. If you can monitor traffic in the kublet, then you should be able to see those requests. And this is exactly what I did there. And on this screenshot, you can see that the API server is actually refusing the redirection. But that tells you also something else. If you look at that traffic, the API server got a request sent in HTTP2. And then you know that you notice that my script was actually finding a response return for HTTP1. So this makes you realize how much important the HTTP stack here is in Golang. So any bug that affects the HTTP stack will have likely a disastrous effect in Kubernetes and thus in AKS. So one thing that I did also, I tried quickly to change some responses. So moving from 300 to, for example, 100, 101, something like that. And that gave me some nice panics on the API server, but really nothing very useful. So coming back to the aspect of attaching WinDebug to Kubernetes. So that worked because in my case, well, Kubernetes was running on a Windows dot, but there are other pods that just run on Linux VMs, and for those one, obviously you can't attach WinDebug. So kubectl is such a pod. It's such an example. And in this case, it was quite easy. You could just terminate the process and quickly start your own web server. And in that case, it would be just super easy to intercept requests and relay them. And that one's another SSRF found there. And the last one, I almost missed it. And you know what? I've been in this area for so many years, and there is one thing that I've realized. I'm really good at missing things. So if you guys want to play with Kubernetes and you want to find stuff, I'm sure that there are plenty that remains. Please send us your research. So why did I miss that? Well, this one was a bit different. So the metric server here is the deployment. This is not a pod. And the way it works is slightly different. Here, you're actually registering an extension. So anything, in this case, any request sent to APIs /metrics.kate.io will be directly forwarded by the API server to the deployment in question. And so if you can hack that deployment, you can play back the same ID and just make those requests bound. So in this case, what I did really was to patch that deployment and make sure that I could just run code for a very short amount of time, and basically just run my own web server and try to rebounce those requests. And that gave you SSRF on another, I don't remember how many pods were affected by that, but a lot. And again, every single one on the CCP. So for example, this request that is highlighted here, you've got VIP 127.0.1. That's basically the API server that is talking to me. And I need also to mention that Weinong Wang from the AKS team helped me a bit about that on this, and he was able to just submit a deployment that behaved exactly the same way. And he told me afterwards that this issue also reproduced on Gkey, which was quite cool. So last thing on this, you see there is a CV. I can tell you I'm definitely not running after CVs, but for a Windows guy like me, I was very proud of this one. CV for Kubernetes, yes, done, I take it. So what's the impact already of those in SSRF? What can you do with that? Obviously, yes, you can leak token. In some cases, you can leak data as well. Can you get RC? Can you get remote code execution there? Yeah, that's a tough issue, and unfortunately for you guys, this is slightly out of scope here. Yeah, well, there is a limit to how much I can say, obviously. It's probably possible. You can, well, one thing that you can do in those cases. The problem when you audit cloud services is that most of them are literally black box for you, and you don't really know what's living in there. You don't have much visibility on what's living in the service behind the scene. So, but in the case of Kubernetes, in case of AKS, the service produce so many logs that you can just go and scrub those logs and try to find some IPs that could potentially be vulnerable by those attacks. You need a bit of experience, obviously, at that, but that's probably something that you can do. But what about today? Well, today, if you try to do the same attacks, well, you just get some very nice panics from the IPA server, which is good, isn't it? Don't worry, I'm sure that there are plenty left. But right now, that's it for me with AKS. So I'm transitioning now to another bug in Office Online. So this is not much related to what I just showed you, but that's still something interesting. So I picked that one. I could have picked something else, but I picked that one because this bug had been reported a couple of times by some external finders. So what is it exactly? What am I talking about? I'm talking about here. I'm talking about the WAPI interface. So what is WAPI interface? So what is WAPI? So that's basically a protocol that that a client can use to tell the backend to use particular files. So in the context of Office Online, where you keep reading and modifying documents, you just send a WAPI request, and each time those WAPI requests, they've got this parameter WAPI source that points to the exact document that you want to modify. Okay? And so, what was the issue? So, a couple of finders came to us and say, hey, we've noticed by just sniffing the traffic that occasionally we would see requests with WAPI source, and we noticed that if we were to replay those requests and just change the host names, then we would get some hit on our DNS server. All right. So when you think a bit about that, a hit on the DNS server, is it a bug or is it not a bug? Well, that's not really a vulnerability here. That's not really a bug. You just see a hit on your DNS server. That just means that the host name had been reserved, but on their web server they couldn't see anything. So it just means that they had found a system, a service that was basically taking a URL, and likely there was some kind of filtering out on those host names. So they were just halfway to finding a real vulnerability. So in such case, what can you do? So the first thing that you should think of is a DNS token. So yeah, so what is this about? This is not new. I mean, Tavis from Google, he published his own tooling about 7 years ago, something like that. So the idea here is that you register your own domain, and in this domain you set some records from some host names, and you set the time to live for those records to 0, which means that each time those host names will be reserved, the DNS won't be able to use its cache. It will need to request again the IP for those host names. And this is particularly efficient here because when it comes to filtering, you can potentially think that there is likely an allow list of IP address, and you could think, oh yeah, so if I can get one of those allowed IP, that I can probably just return it on the first time, and then return something else the next time it's fetched. And yes, that's exactly what was needed here. So in the context of WAPI, we would just need an IP from one of the Office servers, and instead we would return it the first time, and then the next time we'll return something totally different. So I didn't find that bug, but I exploited it. So this is just a request coming from logged on my server, so showing some tokens. But I exploited it to get RC. How did I do that? That's again another story. But I really like that bug because at some point, I just found that thread. It was dug into my inbox, and then I noticed that they were talking about some filtering, and it turns out that I exploited one bug very similar a few weeks before. And so I replied in that thread. I told them that I was a bit suspicious about this, so came up with a POC, and then worked with the dev to get a proper fix on this. And so they fixed that DNS took to issue. And then at some point I thought, I'm pretty sure that there is another way to exploit that, because, well, basically they were only allowing Office IPs. But then, once again, you could try an open redirect on Office. There are some, these are not hidden information. If you can find an open redirect on office.com, then they will just, well, those redirects, they will just forward your request to wherever you want. So this was fixed about a year ago, but the thing is, this is a really common pattern, and the main problem here is that we just don't get those cases. So I've seen those, I've exploited those, but I'm convinced that there are others. But yeah, we need to know this. So, well, I hope that you guys can find stuff similar like that. Once again, SSRFs are absolutely devastating. We ran an SSRF challenge about a year ago. It lasted 2 months. We got some really good results. We're probably going to do the same at some point. Don't ask me when. At some point. And yeah, so if I can encourage you guys to do more research and to find those kind of issues, then yes, let's do it. On this, if you have any questions, then I will be very happy to answer that. One thing, I'm absolutely no expert at Kubernetes, so if you have questions on Kubernetes, I'm not the guy to talk to. But yeah, thank you.